Okay, so this is Test Yourself 18, and we will start with the following. Describe in words each of the first three sequences. So 1A just basically starts with 7, so it starts with 3 and goes up for every term. By 4 every term. Okay, because we can see that the gap is 4 between each one, which means it's a linear or arithmetic series. The next one, 1A part 2, starts with -1 and goes down by -2 every term. Okay, 1A part 3 is going up 3, then it gets doubled. It's getting doubled every time, okay? So we can see 1A part 3 starts with 3 and gets doubled every time. Doubled each time. Okay, that's that part done. Question 1. Okay, write out the first 3 terms of each of the sequences. Okay, so Tn. So we're just going to start with B part 1. T1 equals 3 times 1 plus 1. 3 times 2 plus 1, and T3, 3 times 3 plus 1. We should get 4, 7, and 10. Okay, next one, B part 2, is T1, replace n with 1, equals 1 minus 2 times 1. T2 is 1 minus 2 times 2. And T3 is 1 minus 2 times 3. Now what we get out of this is -1, -3, and -5 when you use your calculator. Okay. Next one, B part 3. We have to replace n with 1, so then we have T1 equals 2 times 1 squared minus 1. T2 is 2 times 2 squared minus 1. And T3 is 2 times 3 squared minus 1. First one's going to be number 1. Second one's going to be 2 times 8 minus 1, which is 7. And the third one's going to be 2 times 9, 18 minus 1, which is 17. Okay. So that's the end of part B. Now we're on question 1C. And for 1C, look at the sequence of these triangle patterns. Draw the triangle of the next sequence. Okay, so draw the triangle of the next sequence. Let's see what we get here. Okay, so imagine it would have 4 balls to each pocket. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. How many dots will be in the 5th pattern? Okay, so what it knows is there's 3 dots in the first pattern, 6 dots in the second pattern, 9 in the 3rd pattern, 12 in the 4th pattern. We can see that this is a arithmetic series going up with 3 each time, so that we know the 5th pattern must be gone up by another 3, which will give it 15. So 15. Find an expression for the nth term of this sequence. So what it is T of n equals a plus n minus 1 times d. A equals 3, d equals 3, So we're going to get is Tn equals 3 plus n minus 1 times 3. Multiply it out. 3 plus 3 multiplied by n, 3n, minus 1 multiplied by 3, minus 3. The 3 and the minus 3 will cancel. We find out that Tn is 3n. This is a formula that tells you what each term is. So for instance, the first term, 3 times 1 is 3. The second term would be 3 times 2, which is 6, okay? Use this expression to find the nth term for which the pattern has 63 dots. If it has 63 dots, this means that Tn must equal 63. Therefore 3n must equal 63. Bring the n down, or bring the 3 down, and we get 63 over 3, which is 21. It's the 21st triangle of the sequence has 61 dots, or 63 dots. Next question. Write down the next 3 terms of the sequence. So this one is going down by 3 every time. Minus 3, so it's going to be minus 2, minus 5, minus 8, minus 11. So that's 2a part 1. 2a part 2. Going down by 10 each time. So we're next going to have 0, minus 10, minus 20. Okay, the third one, 2a part 3. What we can see is it's going up by 1, the second one goes up by 2, the third one goes up by 3, the fourth one goes up by 4. So let's draw this one out a bit quicker, one a bit larger, 7, 11. Now you see that the first difference is 1, 2, 3, 4. Therefore the next difference should be 5. Add on 5, we're going to get 16. Add on 6 to that, we're going to get 22. And add on 7 to the next one, we're going to get 29. Okay, here is a repeating pattern of colored tiles. What are the colors of the next 2 tiles? Okay, so let's see the pattern here. Okay, so we'll make this slightly bigger. Okay, so what we have is red, blue, yellow, green, purple, red, blue, yellow, green, purple, red, blue. The next 2 tiles should be yellow and green. So yellow and green. Write down the sequence form, put the positions of the yellow tiles in the pattern. So the yellow tiles are going to be 3, the third one. So just put numbers on these quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the yellow tiles are going to be 3 and 8. There's a gap of 5 in between the 2 of these. This means that the next one should be 13 and 18. Okay, and this is the sequence. What is the position of the 10th yellow tile? Well, if we keep counting down, so this is the first, the second, the third, the fourth. The fifth one would be 23. The sixth would be 28. The seventh would be 33. The eighth would be 38. The ninth would be 43. The 10th would be 48. 6, 7, 8, 9, 10. Another way of doing this would be to do Tn equals A plus n minus 1 times d. And what this does is it tells you what number in the pattern the yellow tile would be. So if the first yellow tile is 3, A equals 3, D equals 5. So it's going to be n minus 1 times 5 equals Tn. And then Tn would be 3 plus 5n minus 5. And then Tn equals 5n minus 2. It wants us to find the position of the 10th yellow tile. this means n equals 10. So T10 is what we're looking for, the position of the 10th yellow tile. 5 times 10 minus 2, and that equals 48. So two different ways of doing the same question. What is the colour of the 72nd tile? Now to do the 72nd tile, what I suggest is we use an easy number, okay? So what I mean by an easy number is we're going to use the 5th and the 10th one, the purple ones, okay? So if the purple ones are 5, 10, 15, 20, because it has to go up, it's going up in gaps of 5 each time, okay? The purple one should also be the 70th one, okay? And the 72nd one comes 2 colours after purple. And as we can see, 2 colours after purple is going to be a blue one. So the answer is blue. The 72nd tile should be blue. Okay, write down the first three terms. Write down the first three terms of the sequence, seeing that its nth term is given by 2n squared plus 2. Okay, so this is C part 1. All we got to do is replace n with 1. So T1 equals 2 times 1 squared plus 2, which equals 2 times 1 squared is 2, 2 plus 2 is 4. T2 is going to be 2 times 2 squared plus 2, which is going to be 8 plus 2 equals 10. T3 is going to be 2 times 3 squared plus 2, which equals 14. Okay. Now, first 3 series done. Okay, next one. 2, 5, 10, 17, and 26 are the first 5 terms of a sequence. Work out the second difference between the terms. Explain why the sequence is quadratic. A sequence is quadratic when the second difference is constant. And what constant means is a constant. It means a constant value like 3, 5, any number basically, okay? So we're going to find out what the second difference is. So we're going to get 2, 5, 10, 17, 26. Get the first difference. It's going to be 3, followed by 5, followed by 7, followed by 9. Now we're going to do the second difference. And the second difference is the difference of the first difference, which is going to be 2, 2, and 2. Explain why the second sequence is quadratic. This sequence is quadratic because the second difference is constant. Okay. Next one. Which one of the following sequences is linear? Remember, a linear sequence has the same gap between each one. 6, 4, and 0 has a gap of -2 for the first one, -4 for the second one. It's not linear because the gap isn't the same. The second one is -3, -1, 3, 5. So it goes up 2. Plus 2 is the first one. Then it goes up by +4, and then goes up by +2. This is not linear because it's not a constant gap. The next one, which is part 3, -5, -3, -1, 1. It goes up by +2 each time. This means that this one is the linear equation. It's linear. Okay. Look at the matchstick shapes as shown, and then look at the table and copy and complete the table below. Okay, this one has 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is 8, 9, 7, 6, 5 here, and this is going to be 10, 11, 12, 13. So next one is 13. Okay. Now what we can see is it goes up by 4. The next one goes up by 4. The next one should be 17, and the one after that should be 21. Just because it goes up in force. So therefore the 6th one should be 25, and the 7th one should be 29. So the answer for shape 7 should be 29. Find an expression for the number of matchsticks in shape n. It's an arithmetic series, so Tn equals A plus n minus 1 times D. And A is the first term, which is 5. A equals 5, D equals 4. So we're going to get 5 plus n minus 1 times 4. Multiply it out. And we're going to get 5 plus 5n, or say 4n. 5 plus 4n minus 4. And what we should get here is 4n plus 1. Tn is 4n plus 1. What shape contains exactly 101 matchsticks? Remember, Tn stands for the number of matchsticks, so Tn is 101. Therefore 4n plus 1 equals 101. Bring over the 1 and it becomes a minus 1. 4n equals 100. N equals 25th. The 25th sequence will contain 101 matchsticks. Okay. What number goes in the box of each of these sequences? This one's going down by 3 each time. So 1 minus 3 is minus 2. Let's make it a bit larger. Okay. So it's going down by minus 3 each time, and then 1 minus 3 is minus 2. This one here goes down by goes up by 3. 1 plus 3 is 4. This one here has been divided by 3. Divide 27 by 3, we get 9. Divide 9 by 3, we get 3. The next one, the first gap is 2. The second gap is 4. The third gap should be 6. And the fourth gap will be 8. Okay, so that's just a bit of pattern start. Okay, we're on 4b. The first 4 terms of the sequence are 4, 7, 10, 13. Explain what the sequence is linear. The sequence is linear because it's the same gap of 3 between each of the terms. The sequence goes up by 3 each time. Find an expression for the nth term of the sequence. A equals 4, D equals 3, Tn, this is part 2, B part 2, Tn equals A plus n minus 1 times D. A is going to be 4 plus n minus 1 times 3. 4 plus 3n minus 3. And what we get here is 3n plus 1. Use the expression you found to work at the 40th term of the sequence. The 40th term of the sequence means T40. So if Tn equals 3n plus 1, T40 must be 3 times 40 plus 1, which is going to be 120 plus 1, which equals 121. Okay. Now, the first term of a quadratic sequence is 12. Now, if a sequence is quadratic, the second difference is consistent. If the first difference is 3 and the second difference is 2, write down the first 6 terms of the sequence. So what I imagine this means is the first difference means it goes up 12 to 15. Okay, so the first difference is 3. And what I want is that the second difference be 2. Okay, so that means that the second difference is 2. This means that the next difference up has to go up by 5, and this turns it into 20. Okay, and the next difference after that should be 7. And it'll turn this one into 27. The next difference after that should be 9. And it'll turn it into 36. The next difference after that should be 11. And it'll turn it into 47. And the next difference after that will be 13. And it'll turn it into 60. So the answer should be 12, 15, 20, 27, 36, 47. We actually don't need 60. 60 is 1 too far. Okay, so we'll just get rid of that. So that's our answer there. Now, write down the next 3 terms of each of these sequences when the first 2 terms and the term rules are given. Double the previous term and add 1. So 1, 3, double 3, add 1 gives you 7. Next, double 7, add 1 gives you 15. Double 15 and add 1 gives you 31. So 7, 15, 31. Next one. Multiply the previous term by 4 and take away 1. So 1, 3, multiply 3 by 4 and take away 1. And what we get there is 11. Next one, multiply 11 by 4, take away 1. And we get okay, so 4 times 11 minus 1 will get you 43. And finally 4 times 43 minus 1 is going to get you 172 minus 1, which is 171. Okay, next one is add the 2 previous terms together. So for number 3, what we're going to get is add 1 and 3 together, and we get 4. So it's going to go 1, 3, 4. Now we're going to get 3 plus 4, 7. And then we're going to get 7 plus 4 equal to 11. So that's our sequence there. Now, draw a pattern 4. So what we're seeing is the first one is 3. The second one has 2, 3, 4, 5, 6, 7, 8. And the next one has 3, 6, 9, 10. Is it 10? Sorry, the first one has 4, excuse me. So the first one has 4. The second one has 7. The next one has 10. So you can see that it's gone up 3 each time. So in pattern 4 there should be 13, and in pattern 5 there should be 16 because it's gone up 3 each time. So pattern 4 would be 1, 2, 3, 4. The red one in the center, and then 1, 2, 3, 4, 2, 3, 4. Okay, describe the pattern and how it continues. Pattern is arithmetic, is linear or arithmetic. Arithmetic. It goes up number of buttons. Of buttons goes up by 3 each time. each time. Okay. Find the expression for the number of buttons in the nth pattern. In the nth pattern, what we're going to get is the following. 13, 5 is 16. Okay, Tn equals a plus n minus 1 times d. A is 4, d is 3, so a is 4 and d is 3. What happens is 3 gets multiplied in, and what we're going to get is 4 plus 3n minus 3. Then we're going to get 3n plus 1. That's what Tn is. Use the expression find a pattern which uses 25 buttons. This means Tn equals 25. This is part 4. This part here is part 3. And what we have is Tn is 3n plus 1. It equals 25. Bring over the 1. 3n equals 25 minus 1, which is 24. N equals 8. Okay. Next one. Are the first 4 terms of quadratic sequence. Work out the second difference between them. So this is part C. Okay. So it's going to be 2, 6, 12, 20. Okay, so the first differences are 4, 6, 8. And the second differences must be 2 and 2. So the second difference is 2. Use this second difference to find an expression for the nth term of the sequence. Okay, now to find an expression for the nth term of the sequence, what we have to do is the following. We use a formula called Tn equals an squared plus bn plus c. And what we do is we use T1 equals 2 and T2 equals 6. So for T1, now one thing we need to know about A is half the second difference. So A is a half of 2, which is 1. A equals 1. So Tn is currently n squared plus bn plus c. T1 therefore is going to be, replace all n's with 1. We're going to get 1 squared plus b times 1 plus c equals 2. 1 squared is 1. So you're going to end up with 1 plus b plus c equals 2. Bring it over to 1, becomes a minus 1. And now we know that b plus c equals 1. T2. T2 is replace n with 2. 2 squared plus b times 2 plus c. T2 equals 6. We're going to get 4 plus 2b plus c equals 6. Bring over to 4, we get 2b plus c equals 6 minus 4. b plus c equals 2. I say 2b plus c equals 2. Now we have a simultaneous equation with these two equations here. Now what we do is I'm going to change this equation here. Going to multiply both sides by minus 1. I'm going to get minus b minus c equals minus 1. I'm going to put directly underneath. What should happen here is I'll get the following. I'll get b equals 2 minus 1, b equals 1. And then because I know b equals 1, 1 plus c is 1, this means c equals 0. And therefore what it means is, if we go back to the top, I know a equals 1, and I know b equals 1. Therefore, what I can say, what I can do now is, and I know c equals 0, what I can say is that Tn is going to be 1n squared plus 1n, or n squared plus n. And what you have to remember is, what does Tn actually mean? Let's see if it works. If n equals 1, T1 is 1 squared plus 1, which is 2. Works for T1. T2 is going to be 2 squared plus 2, which is 6, which is correct. And finally T3 is going to be 3 squared plus 3, which is 12. So we know we have the correct formula because it keeps working for us. Okay. Next one, number 6. Write down the next two terms in this series. Okay, so we'll just quickly make it a bit bigger. First one goes up by 1, second one goes up by 2, third one goes up by 3, fourth one goes up by 4. This one's going to go up by 5. Next one's going to go up by 6. The one after that will go up by 7. It's 32. Describe in words this sequence. Each time it's getting multiplied by 3. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. Each term is being multiplied by 3. By 3. Okay. The first two terms of a sequence are 3 and 9. If the sequence is linear, write down the next 3 terms. Well, if it's linear, it's going to be 3, 9, which goes up by number 6. Then it's going to be another 6, which is 15. One after that, which is 21. The one after that, which is 27. If the sequence is quadratic, write down the next 3 terms could be. Well, if it's quadratic, what happens is 3 to 9 has a gap of 6. And then if we were to say that the next gap is 7, and the gap after that is 8, and the gap after that is 9. So this is a quadratic term. It's going up by a fixed amount each time. So it could be, this answer could be 3, this would be 16, 24, and then add on another 9 and we get 33. Or another answer could be that it's going up by 2 each time. So the second difference is not 1, it's 2. So what we could get this time is 3 by 9 goes up by 6. The next one goes up by 8. The one after that goes up by 10. The one after that goes up by 12. And the one after that goes up by 14. So what we could end up with here is 17, 27, 39. 39 and plus 14 is 53, so we could end up with a series like that. Now if the series is exponential, write down the next 3 terms. When a series is exponential, it means it's getting multiplied by its, so for instance 3 to 9 gets multiplied by 3. Okay, multiplied by 3. So this means the next is going to be 27, the one after that will be 81, and then the one after that will be 243. Again multiplied by 3 each time. The graphs of these sequences are drawn. Which graph would rise the fastest? Well, we can see that's going to be the exponential, because the gaps become absolutely huge. Okay, so the exponential graph. Explain why there's more than one quadratic sequence that satisfies the pattern. This is because, as I said earlier, this is because the second difference can have. This is because the second difference can be any integer value, which means the second difference, any positive integer value. So the second difference could be 2, as I showed you earlier. It could be 4, it could be 6. So it means that I can go up a different amount each time. Okay. Now, a particular type of bacteria starts as a single cell and grows by doubling. How many cells will be present by stage 6? Well, cell 1, so this is 1, this is 2, this is 4, this is 8. Stage 5 will be 16, and stage 6 will be 32. By studying the pattern, write down the expression for n for the number of cells present at stage n. Okay. N, when n equals 1, cells equals 1. N equals 2, cells equals 2. N equals 3, cells equals 4. N equals 4, cells equals 8. N equals 5, cells equal 16. N equals 6, cells equal 32. Now, okay, let's look at this sequence here, right? This is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. 1 is 2 to the power 0. Okay? So basically, the power is 1 less than the n value. So t of n should be 2 to the power of n minus 1. So for instance, t3 is going to be 2 to the power of 3 minus 1, which is 2 to the power of 2, which is 4. That works. Try t5. t5 is 2 to the power of 5 minus 1, which is 2 to the power of 4, which is 16. That also works, so that's the correct answer. Okay guys, that's this video up, and this will be revision for before your test.